Okay, this is section 2.2 on your chapter of ratios and rates. Chapter 2.1 talked about ratios, comparing parts of a group of objects to another part of the group, or comparing part of the group to the entire group, as in a part to whole ratio. And this section, section 2, talks about a special type of ratio called a rate, in which you're comparing two different types of units, like speed and distance, or cost and mass, to create what's called a rate. So question 2 says 2 brands of canned dog food are on sale. Assume that the cans are the same size. Brand A costs $13.60 for 8 cans, and brand B costs $8.75 for 5 cans. Explain how to find the unit price for brands A and B. Explain how unit prices help you compare the cost of dog food. So how do you find the unit price? Well, in order to find the unit price, you want to first set it up as a ratio of cost to cans. You could also put cost to cans like this if you wanted to, but it's much easier to use them as what we would normally see as fractions, because when we create equivalency, it's much easier to do it the second way. So the first question for A, if we were to take the cost of 8 cans, this is for A, and for B, take that same cost to can ratio and look at it as being $8.75 for 5 cans. In order for us to be able to compare which one's the best deal, we need to know how much each can cost. So what we effectively need to do is take what's called a rate, meaning the cost for 8 cans and the cost for 5 cans, and create a unit rate, where the second term is 1. And what we call this is, we call this proportional to. Proportional to. All right? So just like with equivalent fractions, if I were to divide 8 cans by 8, I would get 1 can. And to keep it proportional, I would also have to divide the first term in my rate by 8. And therefore, if 8 cans cost $13.60, bring this over here, then each of those cans must cost $1.7, or $1.70 for 1 can. So we can rewrite that as being $1.70 per can. And that's how we would write the unit rate per 1 can. And the second one, if I divide both by 5, $8.75 divided by 5 would mean that each can in this particular group is $1.75 per can. And therefore, the best deal is the first one, because per can it's a nickel cheaper. What's the next question we had to do? 4. Thank you. Question 4 is to determine the unit rate of each situation. Now, it is possible to either do kilometers per hour or hours per kilometer. Both of those we can create into unit rates. But given that there's 2 different rates you can make from it, you must choose the best rate, or the most common rate, and therefore kilometers per hour would be the more common one, or rate of speed, and therefore 110 kilometers in 2 hours is how many kilometers in 1 hour? To create the unit rate, we simply divide both by 2, and we get 55 kilometers in 1 hour, or 55 kilometers per hour. That's the work I would expect you to show me as well. In question B, kilometers per hour again would be our units. You could do hours per kilometer, or time per kilometer, how long it takes the goose to fly 1 kilometer, but this is the more common rate of speed. So 800 in 12.5, divide both by 12.5, and 800 divided by 12.5 is 64. And therefore, the goose was flying 64 kilometers per 1 hour. And finally, the last one for Kathy. She plants 45 daffodils in 30 minutes, so 45 daffodils in 30 minutes. Now here we have a choice to make. Both can be unit rates. Did anyone go per minute? Find out how many daffodils she planted per minute. Did anyone figure out per hour? Per hour would be probably a more appropriate one, Because if you did per minute, I believe it's 1.5 daffodils a minute. But if you did per hour, which is also a unit rate, you would simply have to multiply 30 minutes by 2 to get 1 hour. And therefore, it would be 90 daffodils per hour would be her rate. But if you had 1.5 daffodils per minute, that's also okay. And you could also do it per day if you wanted. You could do it per year. You could do it per century if you wanted, but the more appropriate one is probably per hour. Do we have to do 5? No? We did? 5, okay. A blue whale eats 8 tons. That T stands for tons. And a ton, just so you know, in metric is 1,000 kilograms. Right? 1,000 kilograms are roughly 2,000 pounds, they say it. So a ton is roughly 2,000 pounds or 1,000 kilograms of krill in 2 days. So its rate, do we want it per day or per ton? We want it per day, which means our bottom one will be days and our top one will be krill. All right, so krill per day. We have 8 tons in 2 days, which as a unit rate will be 4 tons in 1 day. Now you could also break that down into how many tons of krill they ate per hour. You could divide that by 24. That would also be a unit rate. You could multiply that by 7, and you could say it's 28 ton of krill per week, right? It's up to you which unit rate you choose, but probably more appropriately would be per day. Question B. The cruising speed of a blue whale allows it to travel 193 kilometers in 10 hours. What's a unit rate? Well, we want that to be per hour. So we're going to put kilometers per hour. 193 kilometers in 10 hours will be 19.3 kilometers per hour, which will be 19.3 kilometers per hour. Right? Because when you divide by 10, you simply take your decimal and move it one place over. Right? And the last one, C. A bull moose bellows 15 times in 2.5 hours. So what we really want to know is probably either how many times does a bellow per hour, or we can take it and make that into per day, right? How many bellows per day, assuming it doesn't sleep. But on average, 2.5 hours, so we would say bellows per hour, or 15 bellows in 2.5 hours. Divide 15 by 2.5. We figure out that it's 6 bellows per hour. 6 bellows per hour. Do we have to do 6? Yes? Gina earns $78 for working 6 hours, and Assad makes $192.50 after working 14 hours. Determine each person's unit rate of pay. Who has the greater hourly rate? So we're going to do dollars per hour as our rate. So we're going to do 2. We're going to do Gina, and we're going to do Assad. So Gina is $78 for 6 hours, which per 1 hour, we'll be taking 78 and dividing it by 6. Gina makes $13 an hour, or $13 per hour. And Assad makes $192.50 for 14 hours. Take that $192.50 divided by 14. And Assad makes $13.75 per hour. So who has the greater rate of pay? Assad does, because he makes 75 cents more per hour. Do we have to do 7? No. Okay. Did we have to do 8? Okay. So here we have 3 cartons of milk, and it says, what's the unit price for each carton? So we have a small, we have a medium, and we have a large. The small, we're going to do cost per milliliter. So it's 59 cents per 250 milliliters. The medium is $1.09 per 500 milliliters. And the large is $1.99 per 1 liter, which of course, if we do a quick conversion, 1 liter is 1,000 milliliters. We can't keep it as liters if we have to compare it as milliliters. So what we want to do is we want to make sure that each of these is in unit rates, which means the second term is 1. But we do not want to have per 1 milliliter, because we know that if we took 59 cents and divided it by 250, we're going to get less than 1 cent per liter. So what people usually do is, instead of comparing them in 1, we use 100, which of course is 1 because it's called a 1 hectoliter, right? It's an HL. But we never call it hectoliters. We just say per 100 mils, per 100 grams, etc. So how do I get 250 to become 100? What do I divide 250 by? Well, if you don't know, you can ask yourself, what did I multiply 100 by to get 250? And the answer is 2.5. So if you multiply by 2.5 to get 100, that means you would also divide by 2.5 to get 100. Divide both by 2.5, and you're going to figure out how much this costs for 100 mils. Take your 59 cents, divide it by 2.5, and you figure out that it's roughly, approximately 23.6 cents, or approximately 24 cents per 100 mils. That's how much the small one's costing you. In the second case, if I'm also going to take it to 100 mils, I'm going to divide by 5, because 500 divided by 5 is 100. Take your $1.09, divide it by your 5, and you figure out that this is approximately 21.8 cents, or approximately 22 cents per 100 mils. Slightly cheaper than the small. And finally, for the last one, if I'm going to get it down to 100 mils, 1,000 divided by 10 and divided by 10. This is a much easier one, because when you divide by 10, you just move your decimal over 1. So it's approximately 19.9 cents, or approximately, around to the nearest cent, 20 cents per 100 milliliters. So question C says, which carton of milk is the best buy? Your best buy is the large, because per 100 milliliters, it is 2 cents cheaper than the medium per 100 mils, and it is 4 cents cheaper per 100 mils than the small. Mr. Bridges rode his mountain bike 84 kilometers in 3 hours. Jillian rode 70 kilometers in 2.5 hours. Who is the faster cyclist? So if we take T and J and we decide to write them as rates, Trevor's rate of speed is 84 kilometers in 3 hours. His unit rate, or per 1 hour, I would simply divide both parts by 3 to figure out how many kilometers he would be traveling in 1 hour. 84 divided by 3 tells me that Trevor was going 28 kilometers in 1 hour, or roughly 28 kilometers per hour. That's his unit rate of speed. Jillian went 70 kilometers in 2.5 hours. So if I divide both by 2.5, 70 kilometers divided by the 2.5 hours means that Jillian roughly, oh, I forgot what it was. What was it? Also 28 kilometers per hour. So therefore, who is the faster cyclist? The answer is they are roughly the same. They are approximately the same, LY, the same. They are approximately the same. Sharon buys 12 granola bars for $9.96. Determine the price per bar. So price per bar means our second term is going to be bar. It'll be cost per bar, because I want to get it per 1 bar. And if it's $9.96 for 12, how much is it for 1? I'm going to take $9.96 divided by 12. The cost is 83 cents per bar, which I will write as 83 cents per bar. Explain whether your answer in part A or B is, or A is a ratio or a rate. It is a rate. It is the cost per bar, because money and units are not the same thing. They are comparing both two different types of units to each other, therefore it's a rate. Do we have this one? Okay. This is the last one? Okay, there's one more. The rate at which glaciers melt is increasing globally. The Saskatchewan Glacier near Banff has receded 1.5 kilometers in the last 75 years. For those who don't know, receded just means has gone back. Like my hairline, it has receded, meaning it's been pushed back. Thank you very much. So if we talk about distance to time, and I was to put 1.5 kilometers in 75 years, and I was to then look down here at meters to time for the second glacier, and it was 1,320 meters for how many years? Well, between 1923 and 1973 is 70 years. So we do a quick thing. If I look at these two glaciers, the Saskatchewan Glacier and the Peyto Glacier, the difference is I don't have the same units yet. So I have one that's in kilometers